Hello everyone, I'm Surbhi Gupta from Microsoft and I'm here to present Microsoft AI Network for Healthcare. So let's begin with the key issue because of which we started this project. So as we all know, quality care is uneven around the world. So when we talk about high income countries versus low income countries, or maybe in the same country when we talk about different cities, the care is different, which is mainly due to availability of skilled technicians, clinicians, standardization, as well as limited resources at the point of care. So we thought how AI can help bridging this gap. So AI can help by early screening, by collecting large amount of data from world-class hospitals, building AI models, and provide early screening and prevention. It can provide a standardization wherein every time and everywhere you call the model, it will give the same output. And also by deploying intelligent resources at the point of care where there are limited resources and limited connectivity. So this is the AI network for healthcare where we have intelligent cloud and intelligent edge. We have data collaboratives, which are world-class health providers and institutes. We collect data from them, we get expertise, and in the end, they also validate our models. Using the data, we apply AI on different diseases. So currently, we are in ophthalmology, cardiology, and pathology. We have models for all these fields, and we also have things on the cloud as well as on the edge, so that models can work on offline mode where there is no internet connectivity. And with the help of government and hospitals, we provide last mile care. So these are our health collaboratives. On top right, you can see there are some awards which our team has won. And I'll talk about the active deployments. We are also working with a number of institutes, and Shankara Nitral is also one. And active deployments, we have refractive error API with LV Prasad. Our device partner, Forus Healthcare, we have our models integrated with them. Then Bascom Palmer also for eye care. With Apollo, we are in cardiology. So we have created an API for Indian population which can predict what are the chances that a person can get heart attack in next 7 years. And we have collected a number of health check parameters of the person and some past 7 to 10 years of data for this. And with SRL diagnostic, we are in pathology and mainly we are receiving cancer images. So let's look at a short video of our project.
What if we lived in a world where every medical practitioner around the globe could tap into the learnings and experiences of their peers and seniors? A world where healthcare workers from various socio-economic backgrounds can enhance predictions and treatments to patients using data captured over large. What if we lived in a world where every medical practitioner around the globe could tap into the learnings and experiences of their peers and seniors? A world where healthcare workers from various socio-economic backgrounds can enhance predictions and treatments to patients using data captured over large, high-quality and diverse settings. Presenting Microsoft AI Network for Healthcare, a vision to democratize AI to enable clinical efficiencies and provide better healthcare by bringing together world-class healthcare organizations that collaborate and share anonymized data, medical knowledge, and clinical validation. The network automates this knowledge using Microsoft's artificial intelligence and enables healthcare organizations and governments to apply insights at the last mile care via Azure cloud-based APIs.
So we'll talk about one API and understand the end-to-end workflow. So we have retinal imaging API. We all know the prevalence of diabetes and diabetic retinopathy diseases in the world and how dangerous they are. So we have 422 million people with diabetes, and this number is estimated to go up to 592 million people by 2035. In diabetic retinopathy, we have 93 million people. So as we all discussed, early detection is the key to solve the problem. Now with mass screening programs, what are the current challenges? So there are particular three types of challenges. One is the image quality. So when you go to a rural area, conduct a mass screening programs, and when you come back, you see that half of the images which are taken is not of good quality, and you cannot give any diagnosis on that. The other is of untrained professionals. And one is expertise at the point of care. So there are places where there are limited resources and no internet connectivity. So we basically solved these three problems with the help of, by two ways. One is we created APIs. So as soon as you take the image, it will tell what is the image quality, if it is acceptable or the image should be retaken. Then if the image quality is good, then we talk about the DR. And also, for the expertise at point of care, we have IoT Edge, where we have deployed these models to work in offline mode. So where there is no internet connectivity, it will also give the prediction. And whenever you come back to the cloud, you can upload your all information and images. So these are our image quality and DR detection APIs. First, as soon as you take the image, it will tell whether it's a relevant fundus image or not. Because sometimes they also take the outer eye image or some random images. When it passes that check, then it tells whether it has spotlight, which is hiding the DR features, if the image is blur, if it is sharp, if it has lens artifacts like we discussed, dust particles or the flash. When it passes all the quality checks, then we pass it to our DR detection API. We also detect whether the optic disc is clearly visible, macula is visible, and blood vessel ratio in the image, if the optic disc is cut or faded. When we pass this check, then we detect exudates, hemorrhages, neovascularization, and then give the consolidated report. And also, for the last mile care, as I mentioned, we have these models working in offline mode as well, and we have tried this pilot version with Forest devices. So, like Microsoft and our data collaboration is equal to impact. Thank you.
Thank you. Any questions?
Shubhi, thank you for that nice talk. So, is this available as an algorithm at this point for diabetic retinopathy?
Yes. And there are various pilot versions also going on. So in Andhra Pradesh, we have APPSC, which is Andhra Pradesh Government plus Apollo Hospitals, and they are doing live screening every day. And I think there are some 1,000 calls in a day on these APIs.
So that's across all the patients, not just diabetic patients, right?
That is across all the patients and I think they are adding centers. So right now they have some 40 centers, and every week they have planned to add more.
But those images are seen by a ophthalmologist, if that's correct.
First is mass screening program.
Yeah.
Then there we use image quality thing, and then after that it is seen by ophthalmologist.
Thank you.
Yeah, please. I'm not able to hear you.
Can you use the mic?
Yeah.
For the hemorrhages or the aneurysm of the blood vessels, are they separate model, or is it more like a two-stage model actually use the final diagnosis or screening result actually uses the information from those?
We have one deep learning model which tells DR or no DR, but we have few image processing techniques also in place, and we are not right now reporting exudates and hemorrhages outside, but we have everything working. Whenever our management decide, we'll report this outside, but there is only one deep learning model. Yeah. Yes. 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 So image quality we report in like 4 categories. One is excellent quality, where you have optic disc, macula, blood vessel clearly visible, everything is perfect. Then we report a moderate quality image, where we have little bit problem with blur and sharpness, but still if so we have a parameter in API. If you mention that you need optic disc and macula in a proper position, then that is mandatory. If you mention okay, that's okay, I am okay with the blood vessel and these things, there is a knob to fix that. So there is moderate quality, then we have bad quality, and then there is discard. So images which are non-fundus or which is completely spotlighted, we discard that. But the things are in operator's hand, they can tune. Okay. Yeah. Yeah, we have knob in API parameters, and also the accuracy we report in such a way that for excellent quality images we have this accuracy, but you accept moderate and good quality images, that is the accuracy. Yeah.
One question, I mean, both to Google and Microsoft. Do you have like any image enhancing kind of softwares real time when we take it in telemedicine, etc., we can't expect really crystal clear images, frankly speaking, because it will be done under dire settings. So can image enhancing softwares which are, I mean, either by Google or AI, help to overcome this problem? Because if we are going to have too many ungradable images, then
Yeah.
it's not going to help the ophthalmologist. Then we'll have more number of patients, in fact, to see.
Okay. So by image enhancing, you need a software wherein you can adjust contrast and as well as this contrast and something.
So that it doesn't say it's ungradable, because when we're going to have ungradable images, then automatically it becomes
Yeah.
referable to the ophthalmologist.
See, limited things we have, but obviously if blood vessels are not captured properly or if the image has lot of dust particles and so on, then we leave up to the, we say that the image is of moderate quality with this things visible and this things not visible. Now it's up to the, experts if they still want to go ahead with the image or they want to discard it.
AI wouldn't give a diagnosis.
it it will give a diagnosis, but again the thing is, with good quality images we are more sure, with moderate also we are there, but for bad quality images we are not sure about our accuracy.
You give a confidence interval of your diagnosis.
We mention the quality of image, moderate and good, and then we grade DR and no DR.
So the deep learning model itself has a function of like image processing itself. So one of the strategy we can do is include those bad quality images in the training dataset. And if the information is still there, the deep learning model can potentially learn to enhance the signal from there and make the diagnosis from those previously ungradable images.
Thank you.
Thank you. So really it was a great session, and I'm sure one thing which I felt is that this is one of the first AIOS where AI session is there. I'm sure 1 year is a long time. Next AIOS, definitely I'm sure there will be multiple sessions, because it is coming, it's there, it is not the research now. And not only diabetic retinopathy, glaucoma, AMD, refractive errors, and LASIK. I think another work which has been happening with Microsoft is LASIK. There are a lot of other things which are coming way. So I think we'll see soon the applications of AI more into our clinical practice.